All right, welcome back everyone. Today we're going to go into a deep dive on Amazon's DynamoDB, specifically through the lens of how and when to use it in a system design interview. So we're going to go over the data model, we're going to go over indexing, talk about how to access data, some basics around the architecture as it pertains to scalability and availability. We're going to talk about some advanced features like DynamoDB Accelerator as well as DynamoDB Streams, and then we'll wrap up with, most importantly, when should you use it in an interview and maybe when should you avoid it. So strap in, it's gonna be a lot of fun. Let's get after it. All right, let's start by wrapping our head around the data model for DynamoDB here. There's three key concepts that are really important to know as it pertains to the DynamoDB data model. The first is a table. So all data is stored in collections called tables. This is exactly the same as with SQL. These are just collections of related data. But then within each table, you're gonna have items. Items are just individual records, each with a unique primary key. And these are like rows in a SQL table or rows in a spreadsheet. And then within each item, you're going to have a set of attributes. And those attributes are like columns in a spreadsheet or column in a SQL table, but they're the actual data fields within each item, like the name or the age. And so we can take a look at this example that we have here. This is a basic user table that you might have for any standard application. And the table has a collection of users. Each particular item or row here is a given user, and then the attributes are these columns, or the information about any given user. And so one thing that's important to note here is that not all users have all attributes, and this is okay. So DynamoDB is schemaless. This means that items in the same table can have different attributes. So we could even have a new attribute here, call it, I don't know, employer, and only give that to Sarah and Jimmy, but not to Stefan and Evan here. And that would be okay. This is very different, like I said, than SQL, where you have to conform to a table's rigid schemas with predefined columns. And so there's pros and cons to this, right? On one hand, it's fast and it's flexible for an application. Since we have to change our data structures, there's no migrations. Plus, we only pay for what we store. We don't have empty columns that take up space like we would in SQL, which would just have undefined values. But there's the trade-off. Our application now needs to handle missing attributes, and we need to analyze data across items. It becomes trickier. We can't rely on the database to enforce the data consistency like we can in SQL. And so like anything else, there's pros and cons, and potentially pros and cons that you're going to want to weigh in your interview when you're making your decision. Now, you're probably aware that in SQL databases, we have a primary key that uniquely identifies each rows and helps us with those fast lookups. And so that's what the user ID typically maybe would be here and why it's colored green. Now in DynamoDB, it's simple, but instead we have two things. We have a partition key and a sort key, and these work together to give us those fast lookups and data organization. And so let's talk about each of these. The partition key is a unique identifier that determines the item's physical location. And so what we do is we take this partition key, we hash it using a consistent hashing function, and then this determines which physical node, which physical piece of hardware this data lies on. And then for sort keys, these are optional. You don't need a sort key, but it's a secondary attribute and it enables ordering and range queries within a partition. And so for each sort key, we end up having a B tree index. You can just think of a tree that's kept in memory. And we use this for these range queries, like when we want to get all items between a start and an end time, or when we want to sort, for example, like get all posts in a descending order based on the creation time. And then the primary key is just a combination of these two things. And so it's a combination of the partition key and optionally the sort key. So let's look at some examples, because the reason that this matters is that in your system design interview, if you're using DynamoDB, you're typically going to introduce your data model and explain to your interviewer what is your partition key and what is optionally your sort key. And so if we're thinking about a chat app, well, we'd want our primary key, this should say partition key. We want our partition key to be the chat ID. This means that all messages for a particular chat, group chat, are going to be co-located on the same node, on the same physical hardware. So we don't have to go reach out to a bunch of different nodes and scatter gather in order to get all of the chats, all the messages from a particular chat ID. So that makes sense. And then the typical operation is that we want to sort these by time. Now, what we can do then is have the sort key as a message ID. And I know what you may be thinking. You may be thinking, why is it a message ID and not a timestamp? Well, the primary key has to be unique. And so if you had two messages that were created at the same time, and their primary key is a concatenation of the chat ID and the time they were created, well, these two things wouldn't be unique. It would be a failed write. And so instead, we can have the same properties of having the sort key basically be time by having the message ID be monotonically increasing. And so a monotonically increasing ID, this is just a fancy way of saying that numbers that always go up. And so each new ID is guaranteed to be bigger than the last one. And what this means is that when you sort by these IDs alphabetically, you're automatically sorting by them by the time that they were created, right? And so for a chat application, our partition key is a chat ID. Our sort key thus is the message ID. For e-commerce, maybe our most common query pattern is that we want to get all orders for a particular user. And so we'd make our partition key user ID again to co-locate all of the orders for a particular user on the same shard or the same partition. And then maybe we want to order by the order time. And so we have our sort key as the order ID again, a monotonically increasing ID. And then for social media, it's the really similar concept. Maybe our most common query is to get all posts for a particular user, and we want to be able to sort those by time. So we have the exact same setup. Now these partition keys and sort keys are really effective in ensuring that we can efficiently query for and sort data. But what if you needed to efficiently query by something other than your partition key? Like in this case, maybe instead of efficiently querying by all messages in a chat app, I also, in a different part of my application, need to efficiently query for all messages sent by a given user. Alternatively, what if you wanted to sort by something other than your sort key? So instead of monotonically increasing message ID, so sorting by time basically, what if I want to sort by the number of attachments in messages? Well, this is where secondary indexes come into play. And so we have two types of secondary indexes. We have one, a global secondary index, a GSI, and two, a local secondary index. And so let's look at each of these. A global secondary index is for that first use case, where you want to be able to efficiently query by something other than your existing partition key. And so here's our main table. We determined that our partition key was chat ID because the most common query pattern for us is to get all messages for a given chat. But we now introduced a new page on our website where we show users all of the chats that they've sent across chat IDs. And it was super inefficient because we had to go grab these from a bunch of different partitions, a bunch of different physical nodes. And so to solve this, we create a global secondary index on a different partition key, in this case, on the user ID. And so now both of these things exist. It's almost like a replica of the table. And for our global secondary index, we can optionally project any of the attributes that we need here. And so only the ones that we need in order to be conscientious of our storage would get projected over here to this global secondary index. But now, regardless of whether users are querying to see all messages of a chat or all messages sent by a given user, they can do so efficiently because we have this global secondary index. And then local secondary indexes, as you're probably catching on already, this is for the case where we want to sort by something other than our existing sort key. And so we have the same partition key. In this case, back to our example, we have chat ID as our original partition key and the monotonically increasing message ID so we can sort by time as our sort key. But now we want to also be able to sort by the number of attachments. We have a portion of our chat application, which is maybe it's like Slack. There's a lot of attachments being sent. And we want to be able to see the messages that have the most attachments so that we can find attachments. I don't know, a bit contrived, but you get the idea. And so we can create a local secondary index where the sort key for that local secondary index is the number of attachments. And so basically now we have a B tree for message ID so that we can efficiently do range queries and sorts based on the message ID or the time. And we also have one for the number of attachments so that we can do the same. And so in your interview, this is relevant because if you find use cases where you have two different functional requirements maybe that require different query patterns, then you can emphasize to your interviewer that you're going to create a global secondary index or a local secondary index respectively, and you can mention on what new partition key or sort key in order to accomplish your goal. All right, switching gears just for a moment. While you don't directly need to know this for an interview, I always learn best when I can see something practically applied. So how do you actually create a table and query it with DynamoDB? Well, first off, it's dead simple. You go to the AWS console, you click on DynamoDB, you create new table, and it takes you here. You specify your table name, what your partition key is, and your sort key. Down here, there's an additional button. It's defaulted to leave the custom settings, or the default settings. Alternatively, you can hit custom settings and then specify some global secondary indexes local secondary indexes. You can also always build those after the fact. So it's really that simple. It's a couple button clicks. What about with querying? So if we come down here, you can see what this looks like. In SQL, and you're probably familiar with this, if I want to query all of our users from our user table, it's just select star from users. That's how we do a full table scan there. In DynamoDB, what you end up doing is that you'll have some SDK in whatever your native programming language is that allows you to query DynamoDB. And so, for example, if it's JavaScript, you'd have dynamodb.query, and then you pass in some parameters and it returns your data. And so let's look at what the parameters in each of these cases would be. So for select star from users, it's just specify as the params the table name, and that's going to return to you all the items in that table. Now, a little bit more complicated, what if we want to add a where clause? So we want to select star from users, but only where the user ID is 101. Well, now our params is still table name users, but we add an additional expression and we specify the user ID needs to equal some ID, and that ID is 101. So pretty straightforward, rather intuitive, easy enough. Let's look at one more here. What about in the case where we want to sort? Right? So we want to sort by some order date. This is that sort key comes in handy. And so now we can have that table name of orders. We can still have some condition like we had before, but we'll have this scan index forward. And so if you put this as false, it's descending. If you put it as true, it's ascending. So it's a different language, a different query language, but it's directly there within your code. It's rather intuitive, easy enough. There's actually one other thing I want to show you, and that's transactions. And so I've alluded to this a handful of times. I think I'm going to continue to do so. Transactions were introduced in DynamoDB in 2018. A transaction is just a way to ensure that a group of operations either all happen successfully, atomically, or none of them happen at all, just like in a SQL database. And so typically it was like if you need atomic operations, then you would have to go with a SQL database in your system design interview. Not anymore. DynamoDB supports transactions. And so see how it does it. Begin transaction, this is in SQL, and then we have two things that we want to do here. This is in the case where we want to remove $10 from someone's balance and add $10 to someone else's balance, like in a banking application. And here's how we would do it in DynamoDB. We would do dynamodb.transactions, transact write, and then we just have a list of the two operations that we want to have happen. So in this case, reduce 100 from one person and add 100 to someone else. So super cool. DynamoDB even supports transactions. You can tell your interviewer that. Now let's talk just a little bit about what's actually happening under the hood here. And so we've chatted about how DynamoDB scales by using consistent hashing on items partition keys in order to determine where to physically store the item. And so just as a reminder, and I have a diagram here for you, consistent hashing works by mapping each node in the system, each physical piece of hardware, or you can also have virtual nodes, but let me hand wave that for a moment, to an assigned position on a circular ring. And so here you have a circular ring. It goes 0 to 100, at least in our contrived example. And then what you're going to do is you're going to take some partition key, you're going to hash it, and that hash is going to create some number. Sometimes you may need to take a modulo so that it falls on the ring, but regardless, you're going to pass it through some function so that it's going to give you a number in our contrived example, 0 to 100. And so we're going to go to that point on the ring, in this case, 28, and then we're going to walk clockwise from there until we find the first node. This is the node that that item is stored on. And so the nice thing about this is that if you remove nodes, like for example that one, then the only things that are affected are the direct neighbors. Nothing needed to be redistributed over here, for example. And so there are plenty of videos online about consistent hashing. They go into far more detail than that, but I just want to do a quick reminder there and emphasize that that's what DynamoDB is using under the hood on the partition keys. Now, when it comes to fault tolerance, and availability, DynamoDB is using asynchronous replication. And so this just means that all writes come into a single leader node, and that leader node then asynchronously forwards that data on to replicas that are in different physical locations, different availability zones, they're called in DynamoDB. And so DynamoDB actually, this is fairly interesting, it uses something called sloppy quorum, which means that even if some network connectivity is severed, like here, boom, boom, it's a white pen, so you can't see that, but imagine network connectivity was severed there, then we temporarily allow writes even during those network issues, and we just fix any of those consistencies later behind the scenes. Cool. So that's what's happening there. Every time you write to a leader, you asynchronously replicate. Now, in the majority case, in the default case, we can read from either the leader or any of the replicas. But this just might mean that you have some slight eventual consistency. So if somebody in some part of the world just wrote some data to the leader and it had only been propagated to the replica 1 but not to replica 2 yet, and someone else was reading data from replica 2, they may have slightly stale data on the order of, maybe milliseconds, depends on what your network congestion might be. But that's the eventual consistency case, and that's the default for DynamoDB. But, where was it? I had a box here somewhere, but bang! In 2018, DynamoDB introduced support for strong consistency. So now, while the eventual consistency is still the default, you can enable strongly consistent reads. And what this means is that if you have strongly consistent reads enabled, then all of your reads are going to come off of the leader, and you're not going to have any of that replication lag. And so this can hurt some of your scaling. This has some downstream negative consequences. But more importantly, what it means in your system design interview is that in your non-functional requirements, when you consider CAP theorem, and you're going to decide whether you need high availability or strong consistency, it used to be the case that if you chose strong consistency, then your database choice almost necessarily has to be SQL. That's not the case anymore. Now you can explain in your interview that I need strong consistency, which just means that I'm going to enable strongly consistent reads within DynamoDB. And just like we were showing earlier, this is super easy. It's just a configuration in your AWS dashboard. You're just going to check a box. Pretty straightforward. All right, at this point, you have the basics down. You largely have everything that you need to know in order to introduce and use competently DynamoDB in a system design interview. But I want to introduce some advanced features here that are supported by DynamoDB that are really neat and handy to pull out in your interview. The first one is DAX. It's short for DynamoDB Accelerator. And what it is it's a built-in cache. It's an in-memory caching layer that provides microsecond response times for heavy read loads with automatic read-write-through caching. And so what you can do in your dashboard is you can enable DynamoDB Accelerator, DAX, and this is just a caching layer that's going to sit in front of DynamoDB automatically. And now you can query this cache and you can configure how you want to handle your eviction policies and things like this. But the important thing to note is that if you introduce DynamoDB in your interview and then you decide that you need a cache, in most cases, not all, but in the overwhelming majority of cases, you want to say that you're just going to enable DAX, not that you're going to introduce Redis or something else. This would be suboptimal for you to do something like that. So let's look at an example of a place where you would need this. It's the same place that you would need a cache generally, but let's say you had a system design interview for something like Yelp, and you were designing a basic review service for businesses. So you have a client, you have some business service, and then it interfaces with DynamoDB, which has all of the business information. And maybe you want to make retrieving businesses faster by ID. I would argue you don't really need to enable DAX for this. You're already at single-digit millisecond latency with DynamoDB. Do you really need microsecond latency? Probably not. But what if there are some queries that are a little bit more expensive, like a query to get all of the reviews and find the average review? Now, of course, there are other ways to do this, but bear with me for the example. It might be that you just cache the results of that query in DAX. And in doing so, now you've significantly reduced your latency because you don't have that quote-unquote more expensive aggregation. It's just as simple as enabling DAX. And so in your interview, you can say as much. I have DynamoDB. In order to make sure things are more efficient, I'm going to cache this data by enabling DAX. Cool. Let's look at the second one here, and the last one of the advanced features I want to introduce that's useful in a system design interview. This one's DynamoDB Streams. And so if you've watched any of our other videos, you've seen me use sometimes change data capture. And what this is it basically means that you can track any table modifications. So changes that happen in DynamoDB, like inserts, updates, deletes, etc., they can trigger some downstream process. This downstream process could be like to put it into a queue, to have some Lambda worker do something off of it. One concrete example is here. Let's look at this. Imagine that you're designing Ticketmaster and you have an event service which has an events DB and it has all the events that are available to users. But users need to be able to search for events. And this searching through events is fairly complex and expensive. It has geospatial queries. It has full text search, etc. And so we opted to use a search optimized database like Elasticsearch. But now we want to make sure that these two things remain in sync. They remain consistent, at least eventually so. And so one thing that we can do is just have every time a new event is added or updated to the events DB, we can use DynamoDB streams, DDB streams, in order to make sure that that update is reflected in Elasticsearch. And so you would configure DynamoDB streams here. You would have some Lambda, like this drawing is how we do it in a system design interview typically, but it's an abstraction. You'd have some Lambda here that takes any changes and then goes and issues some query to Elasticsearch or some write operation to Elasticsearch in order to update the data there accordingly. So if you need CDC and you're using DynamoDBs, you can just say that you'll use DDB streams. All right, so let's answer the million-dollar question that you are all here for. When should you use DynamoDB in an interview? Well, the reality is, for most system design interviews, DynamoDB works great. So my answer is like most of the time. But in the same way, Postgres works great. So if you ask me the same question about Postgres, I would say it also is most of the time. These technologies and databases have converged so much that they all, or at least a large percentage of the most popular ones, work for the majority of cases. Don't overthink this. But the more interesting question might end up being, when should you stay away from DynamoDB? And I think there's 3 rules that you can follow here. The first is if you have really complex query patterns. And so this is going to be joins across a bunch of tables, a lot of subqueries. Then it's true DynamoDB might be able to pull this off with proper modeling, but a SQL database is still probably the better tool for the job. And then second is that if you need transactions across multiple tables, DynamoDB can support this, but there's a limit on the number of items that can be items again, or rows, right? That can be in a given transaction. I think this number is at 100 right now. Don't quote me on that. But this may or may not work for your use case. So it might be something that you want to stay away from and use SQL for instead. And then lastly is if you have complex data modeling. Typically the sign here, at least in production, is if you have a ton of GSIs or LSIs, global secondary indexes or local secondary indexes, then you may be abusing DynamoDB a bit and you should consider going with SQL instead. But all in all, the main takeaway, and I think we suggest this on the website as well, if you're going to learn 2 main databases for your interviews, I would learn about Postgres and I would learn about DynamoDB. And you can largely use either of them in just about any circumstance, and you'll want to weigh just some of these pros and cons appropriately in order to make the most effective decision. All right, so zooming out here, both figuratively and literally, you can see that we've covered a lot of ground in a fairly short period of time. So you should have the basics under your belt, how to use DynamoDB in a system design interview. You should be feeling more confident. Of course, my advice from here is to go actually play with it. There are free accounts with AWS. You can set up a simple DynamoDB instance, query it, have some fun, get some practical experience. But this should equip you with most of what you need in order to answer interviewers' questions and have a pretty comprehensive understanding of when to use it in an interview. So thank you all for watching. There'll be more of these. If you have questions, please leave them in the comments. Of course, if I said something wrong, let me know in the comments. And as always, good luck with your interviews. Talk to you soon.